AWS Lambda support many languages through supported runtimes. These support some of the most popular languages like Java, Python, JavaScript, and Ruby. They also allow you to use your own custom runtime, which allows you to use more performant languages such as Rust and Go. Now, why would you go through the trouble of using something custom when you can use a scripting language like Python out of the box? A couple of advantages to using Rust. First of all, you have type safety. You have an opinionated compiler that's going to help you catch bugs before you even publish your Lambda functions. Of course, you get that sweet performance. Going over some benchmarks. This is running a simple function. This isn't doing anything too crazy, just a call to DynamoDB. Now, onto a computationally heavy function. And this is where Rust really shines. And you can see how well Rust is performing on various different Lambda sizes. I'm just going to go over what you would actually need in order to follow along and create your own Lambda functions using Rust. These installation steps are going to be different depending on what system you're using and also when you're watching this video. To help out, I'm going to add some links down in the description that will go over where to sign up or install these various things that you will need. First things first, you're going to need an AWS account. Then using IAM, you're going to want to create a CLI secret key. Do take note of that key because you're going to need that to use the AWS CLI. Now, we need to install the AWS CLI. You're then going to want to run AWS config and put in your key and your secret when prompted. We're going to want to install and set up AWS CDK. CDK allows us to have our infrastructure as code using our favorite programming languages. Install Rust using rustup. This means we'll get cargo, the package manager, and the formatter, and other nice features as well along with Rust. Finally, we want to install cargo lambda. This is what's going to allow us to create a Lambda function using Rust. What we're actually making. We're going to use cargo lambda to set up our initial project. We're going to use AWS CDK to create a Dynamo table for us and also manage our Lambda. We'll add a couple of emails to our new table that we created using the CDK using the Rust SDK. We'll also go over how to query a DynamoDB table in Rust. Finally, using AWS SES, we're going to send out an email to all of the emails that we got from our table. CD yourself to your project directory and then run cargo lambda new, call this whatever you want. CD into your project and run Smux to open up a couple of terminals, and in this one I want to run just open up the project in your text editor. We open up the cargo table. There's actually too much going on here. We have Lambda HTTP, and then we have Tokyo. Well, Tokyo helps us work with async. And the main chunk of this function is actually going to be happening in this HTTP handler RS. As you can see, there's a lot more code that's being generated. Majority of this is tests, which I'm actually just going to remove because while we're on the process of deleting stuff, I'm just going to get rid of a benchmark because I want to keep this as simple as possible. It's going to do sort of that, do a pick our own sort of string from. It's not going to use this string again. Hello from our Rust Lambda. Now to actually run this locally, you can run cargo lambda watch, which will first build our function, and then we can run it locally on localhost 9000. Now that's built, let's go over to our browser, open up localhost 9000. Hey, there we go. Hello from our Rust Lambda. Let's go ahead and actually build our Lambda function production ready. We can go ahead and run cargo lambda build and use that release flag. But to deploy our Lambda function, I'm just going to use AWS CDK. Let's create a new directory called deployment. Then cd to deployment and run CDK init app. I'm going to use TypeScript. Jump back into your text editor and let's open up lib/deployment stack, which is in deployment, lib deployment stack. This is where I'm going to define a Lambda function as code and all the sort of other bits we need for our project. I'm going to create a new variable that's going to store the definition of our Lambda function, and that's going to be a new function. I'm going to need to import a few things for this to work. So, okay, so it's going to be a new function, and let's take this, and we can name this whatever we want. I'm just going to call this Rust Lambda function, and that takes in an object, row a config. We're going to add a URL, so we can trigger this Lambda function by going to said URL. So I've done it outside the actual class here, haven't I? So take that code. There, so do a format there, so my indents for me. Okay, and a space there, to make it a bit more readable. Do it. Yeah, so we're already importing the CDK. We're doing import everything as CDK. So CDK, let's do a CFN out. And this is just when we're building deploying our project, our CDK project. We'll actually print out the value of this URL. The URL part of that. I don't want to make a constant, that doesn't make sense, so I just want to do new. That's a capital C, okay, CFN output, just like that. Cool, yeah, do a CDK deploy and hit Y when you're prompted. So it's going to say here, these are all the things that are going to change, and deploy as a result. When you want to go, open up that Lambda function URL. Now if I switch over to my browser, I can see hello from our Rust Lambda function, and this, but while we're making changes to our AWS CDK, we're going to add a table using Dynamo. And we are also going to want to add, I can probably close that down now. We're going to import everything as IAM from AWS CDK /lib/AWS IAM. Yeah, we're just going to go below where we define our Lambda function. Here, we'll do a const email table. It's going to be the variable we're storing our email table config in. Do DynamoDB table. This is the name of our table. Finally, removal policy. What do you want to happen to our table when we destroy our CDK stack? Now, in my case, because I'm just doing this not for actual proper production code, I'm just doing this as playing around, demonstrating. I want this to be destroyed. to clean up the resources. Well, before we can actually use this in our Lambda function, we have to add some policies using IAM. So our handler, so this is our Lambda function. Which resource do we want? So it's always good to tie this down. So what you could do is, if you wanted this to allow you to do anything to all of your tables, you can just do start, but no. Because we actually have this in scope here, the email table, it's really simple to just say email table.table ARN, and that will ensure that we can only, this Lambda function can only do these things, so scan and put item on our email table. We're not really going to worry about sending emails just now. First we're going to set up a table, add some items to a table, but later on we are going to need to send emails. Well, while we're at it, we may as well CDK deploy, just to make sure we haven't made any mistakes. So CDK would always show you your changes and ask, do you want to go ahead with these changes? One thing I just noticed, I haven't actually set up the region. If you just want to use your default region that you have set up in your AWS config, no worries, ignore this step. But if you are like me and you actually want to deploy it to a different region than you have in your AWS CLI config, then you can do a define the end that has a region. I'm actually going to set mine to EU West 2, as that's where I've got my AWS SES properly set up. I'm going to delete all these comments just to make it a little bit neater. It's a bit nicer for my eyes. Now I've actually just popped into AWS the console, and I can see we got an emails table there that is actually deployed a DynamoDB table for us. But let's get to actually adding some emails to our new email table. We have this table. We're going to want to add some new dependencies to this. So I'm going to go back to the root of our project. We're going to do a cargo add. We want to add in the AWS CDK DynamoDB. A few more crates we want to add. So we're going to do a cargo add AWS. This isn't really related to adding emails to our table, but more in terms of sending emails. So we're going to need SES at some point. There's what I'll add it out. And then also want to add in the AWS config for setting up our SDK clients. And UUID editor, let's have a look at our table. For UUID, we actually want to use a specific feature of this crate. So I'm just going to wrap this in brackets and then say this is going to be the version property. Which is what's happening with Tokyo Birth as an example. And futures, we want, did I spell futures right? I did, yeah. I just had to add equals for it to change colour. I'll just assume I misspelled it there. And then V4, cargo build. Let's get back into the code. We're going to go into our HTTP handler. We're going to import some of those packages. Clean up some of these comments. We're going to go here, read down, remove those, and then inside the body of our function, let's first create the config. This is the config objects that will read our AWS credentials, make sure we have permissions to do what we need to do. important step, setting up our DynamoDB client. We're going to create a new function for adding emails. I'm going to go to the bottom of my file here and do a new async function, add email. And this is going to take in a few things. First of all, we want the client. Then we're going to want the email that we want to add, which is going to be a string. What's this going to return? It's going to return a result. AWS CDK DynamoDB. This is the put item output. Or alternatively, more import before we get rocking and rolling back into our add email function. Let's have this ID AV attribute value, which is going to be attribute, well, it needs to be equals, what's this going to equal? It's going to use for an attribute value that we're importing above from the DynamoDB SDK or CDK. It's going to be S for string. The value of this is going to be UUID new v4. Convert that into a string. Brilliant. And the email attribute value is going to be attribute. You're going to notice a pattern here. It's going to be a string. This is sort of an optional, but something that is required when using the AWS SES, is you have to allow people to unsubscribe from your emails. So I'm going to have a subscribe attribute value. So I'm going to create our request, which is going to come from the client. We're going to use a put item method here. Table name. This should really be a const, but we're only going to use it a couple of places maybe, so I'm just going to be lazy and pass it in as emails. And item ID, it's going to be our ID attribute value. And finally we need to get a response back. So we can actually call this request using the send method, and this needs to be awaited. Return that request. We can see we've got a warning here because we're not actually using this function yet. Let's go ahead and change that. So if you remember before, we can run cargo lambda watch browser here. I can show you I have added 2 emails. I want to create another function that's going to query our emails table and then grab every single item from there so we can send out our email to those guys using SES. Create a new function called get all items. Make it generic because you could really pass in any table and it will grab every item from said table. So again, we're going to take in a client, which is going to be a DynamoDB client. I'm just going to take in a table name, which is going to take in a string. So it's going to return, it's going to return the result. It's going to return a vector of a hash map, and inside that hash map we're going to have a string and an attribute value. Use autocomplete when I can. So let mute items, it's going to be a mutable variable here. It's going to equal a new vector. Just initializing that, an empty vector. We're going to have a last evaluated key. And the reason we're doing this is because Dynamo only gets back so much data. Can't remember the amount, it's some amount of megabytes, or maybe even a megabyte or so. But either way, in order to get every single item, we need to check if there's any more items in the table, so we're going to have to do a loop. Okay, client, and then we want to scan. Use that method, pass in our table name, which we get in the parameter, and then set start key, which is going to be our last evaluated key. Sends that off and await it. So we're creating this new variable, new items, which is going to be everything that we grabbed in a response, in a scan table response, and we're setting, just appending those to our items vector that we defined outside of the loop, so we can access that later. And then finally, before our sort of loop iteration ends, we want to set the last evaluated key to be whatever's come back from that response. If, don't do parentheses, if last evaluated key, it doesn't exist, so that means we've finished going through all of the items in our DynamoDB table and appended them to our items vector already. Simply break out of the loop. Okay, I'm getting an issue with this function, and it's because I'm not actually returning anything. So I want to return items. No, it says from Rust, but I'm going to ignore those because I'm not a Rust professional. I just want to show you guys how you can use Rust with AWS Lambda, because it is a fast type-safe language. So let's just give this function a run. So I'm going to create another variable called raw emails, which is when we're setting our raw emails variable, we do in fact need to await. I'm actually running into a error here because we have moved the table name. We've actually put it inside the loop. So instead of passing down a string, I'm going to pass down get all items here. Now instead of string, we're going to change that to a reference of a string. And I think now if I just add a ampersand here, now it looks ugly, the output, but you can see we're getting these IDs, they're nice and random. That's our UUID in action. Subscribed, but all true. Email, that's a string. So it gives you the attribute type and then the value inside it. It's a bit nasty, the structure, so we're going to have to map through and parse that data to make it a bit more useful for us. Back in our code, let's pass those emails and create a vector of just emails that we can use to actually send to SES and get this party started. So emails is going to be a vector, that's going to have a string. That is what we want. And in order to get that, we're going to have to iterate through these raw emails. So do an iter. And we're going to use a filter map because we don't want all of the information that we have in raw emails. So let's going to give us do an item get, which will try and get us the subscribed item, but it might not exist, so we have to do a and then. Now we're doing this because if somebody is unsubscribed, which they might be, do a map. We want to do those subs. We're going to have to dereference subbed filter. I don't know what to filter out the. So this is going to be a boolean, true or false. So we can just do that, and that will filter out the people who are not subscribed to us. Okay, and then just need that. So it's going to create happens an underscore. We just need to iterate through the data. We're going to do an item get email. We're going to use a match here, email object as a string. And let's open up that match. Is it okay? And if it is, we'll return that. So this is going to be the actual email. We want to return it as a string to match what our effector wants to see. And then the other arm of our match is going to be the not okay one, the error. And if that's the case, don't want to return anything. And finally, go back down to the bottom of our filter map and hit run and collect. One way to find out, and that is by logging them out. So just making sure Cargo Lambda is still running. I'm going to go back to localhost 9000. Emails passed. Whoa, we got our emails in a vector of strings. Let's send some emails. So here, going to import a bunch of stuff. SES client, SES client, new, and passing the same config that we did for Dynamo. Stage 1 tick. We're going to create a new async function, send email. Now we're going to set the sender of this to be whatever email address we have set up in AWS SES. Set the subject of our email to be a string. This could be anything. Body text. Again, this can be anything. This is going to be the actual content of the email, the actual body. And we're also going to create a body HTML, which is what people will see when receiving an email if they have HTML downloads or whatever enabled, or if it's like a trusted sender. Do ignore the error, that'll be sorted once we sort out the return type of this function. It's going to get a bit more complicated. We're going to use something called the builder pattern, which is Rust's way of creating complex objects. We'll start with a simple example. That being said, let's create our destination. It's going to be the object of where we want our emails to be sent off to. So we need to do a destination struct, which is going to call this builder method. You're going to see a lot of that soon. On that method, we have this set BCC addresses, which is just going to be all the people we want our email to go to. We're already passing that into this function, or we will be, recipients, and this needs to be some, and we're going to call build, which is always going to be the final step of these builders. We're going to be using the same sort of technique to build a bunch more of those objects in our send email builder. I'm just going to call it that variable. which is going to call the SES client that we're going to pass in. That's going to call the send email method. That needs a destination. I've already built the destination, so we can just simply pass in that variable. Now, this also requires a message, and message, same like destination, has a message struct which has a builder, and that has a few methods attached to it, like subject, which is what we've created up there. So that's going to be content builder. So it's going to be another builder object which has a data method on it, which is where we're actually pass in our subject, and that now needs to build. And now we're still within that message builder. We also have the body object. Now body object will have the email, we'll use the email body.text, which is what we're going to pass in our body text to. Now we need to do very good, and then we have text. Now we want HTML, which we're just going to do the same thing. This was within the message builder, and we haven't built that yet. So I'm just going to go down here and call build. And then finally, we need to set who is sending this. And that is going to be our sender variable. Okay, let's send off our email builder that we have been setting up. We're going to send method on it, and we're going to await that. And then finally, wrap that in an OK and send a response back. And hopefully, ooh, got some issues here. Yeah, I've just spotted it. So I'm building the text content builder, building the HTML one. I'm building the message one, as you can see right at the bottom here. I'm not building the body one though. So we need another build. I told you it gets complicated. You know, it started off simple with destination, and then this one just is pretty wild, but that's all happy now. Okay, so yeah, we've got our emails. We're printing out the emails again. I'm going to get rid of that print because we know it's working now. Just had that in for debugging purposes. Now I want to actually send email, and that's going to take in a reference to our SES client and the emails. Oh, and don't forget to await that. Question marks could fail, and then finally let's do a println emails sent. Then I'll do another print here just so we can sort of see if it's falling over before. It's always good to have more prints than you need when you're just sort of debugging and testing things. Always fine. So out to send emails. Let's go. Just clear that. Run a watch again. No, I probably don't need to do that, but I like to anyway. I'm going to open up my browser. It's so quick. I'm using Rust. It is rapid. Brilliant. Let's have a look. I'm going to check my inbox now. Look at that. Hello from AWS Lambda. That's our subject we set. Written in Rust, 7 in AWS. That's neat. All that's left to do is to deploy our codes, because this was just running locally, and actually get that sending from our production. I've literally just moved place, so sorry, the background's a bit empty. Way too empty. So let's get some furniture. Got the computer set up though, that's like the most important thing, of course. Right, so just wanted to play around to see if it was actually possible to write a Lambda function using Rust. And I was impressed with when I saw a blog post saying that with the performance benchmarks. And so, yeah, okay, not only is it possible to write a Lambda using Rust, it is blooming quick if you do. Now, for me personally, as a Rust noob, I'm still learning it. I'm getting used to it. I'm trying to use it when I can. It takes a long time for me to write anything in Rust. So I'm battling with the type system. It's, you know, if I was to do the same thing that we just went through in Python or JavaScript, a scripting language, it would have been miles quicker. However, you wouldn't get those performance benefits or the type safety of knowing that, you know, your code's probably not going to explode and error a bunch of times because you've got that Rust compiler nitpicking at you, making sure that what you're writing is solid. Either way, I learnt a bunch playing around with this, I had fun, and I hope you learnt something too. Thank you for watching. See you later.